Hey everyone, I hope you're doing well today. In this video, we're going to do a proof together. While I know proofs can be a bit frustrating, hopefully I can help simplify down the process of how to write this proof. If you'd like to try this proof on your own, go ahead and pause the video now. Otherwise, let's get right into it together. As usual, let's see what we're given from the start. First, we're told that segment DE is congruent to segment FG. And on the figure, I'm going to mark them with 2 tick marks each. Next, we're given that segment GD is congruent to segment EF. On the diagram, here they are marked with 1 tick mark each. And the last thing we're given is that angle HDE and angle KFG are right angles. Here's angle HDE and here's angle KFG. Both of them are right angles. Given these 3 pieces of information, we need to prove that segment DH is congruent to segment FK. As usual, our first statement is going to be our given information and the reason is going to be given. For statement 2, I'm going to go ahead and say that segment GE is congruent to segment GE. The reason for this is going to be the reflexive property, which just means that a segment is congruent to itself. If you're wondering why we wanted to say that segment GE was congruent to itself, hopefully it makes sense when we take a look at step 3. In our third step, we can say that triangle GDE is congruent to triangle EFG. Here's that first triangle, and here's that second triangle. Getting rid of a couple extra lines, hopefully you can see these triangles a little bit more clearly. By stating that segment GE was congruent to itself in step 2, that gave us a third side to say that these 2 triangles were congruent using SSS or side side side. Now that we know these 2 triangles are congruent from step 3, we can go ahead and make the statement that angle GDH is congruent to angle FEK. The reason for this is going to be CPCTC. Once we knew that these 2 triangles were congruent from step 3, we were able to say that the corresponding angles of these 2 triangles are also congruent. Similar to step 4, we can say that angle GDE is congruent to angle EFG. The reason for this is also CPCTC, since these are also corresponding angles for these 2 congruent triangles. For step 6, let's say that angle GDE is equal to angle GDH plus angle HDE. On top of that, we can also say that angle EFG is equal to angle EFK plus angle KFG. And if you need a moment to think about those angles, go ahead and pause the video right now so you can take a peek at them. Hopefully it makes sense that these 2 bigger angles of GDE and EFG are made up of those 2 smaller angles, and the reason for this is going to be the angle addition postulate. Before we move on, let's pause for a second and remember something we were given earlier. These angles of HDE and KFG, remember from earlier that we were told that they were right angles. That being said, instead of writing those angles, let's change those to 90 degrees because that's a definition of right angles. While I didn't write this as a separate step, feel free to do so if you need to. This larger angle of angle GDE is made up of the smaller angles of GDH and 90 degrees. And this other larger angle of angle EFG is made up of 2 smaller angles of angle EFK and 90 degrees. Because we already established earlier that these larger angles were congruent in step 5, we can go ahead and say that the sum of their parts are also congruent. In step 7, we can make the statement that angle GDH plus 90 degrees is equal to angle EFK plus 90 degrees. All we did was swap out the 2 smaller angles for the larger angle using the substitution property of equality. In step 8, we can go ahead and say that angle GDH is congruent to angle EFK. The reason why we can say this is that from step 7, we can subtract 90 degrees from both sides of the equation using the subtraction property of equality. Now that we know that these 2 angles are congruent, that leads us to step 9. In step 9, let's go ahead and say that triangle GDH, which is this triangle right here, is congruent to this triangle here, which is triangle FEK. To make this a little bit more clear for you to see, let's get rid of the rest of the figure so that we can just focus on these 2 triangles. Hopefully now that we're just looking at these 2 triangles, we can see that they're congruent by using the angle side angle theorem or ASA. Now that we know that these 2 triangles are congruent, we can finally say that segment DH is congruent to segment FK. Since we established in step 9 that the triangles were congruent, then we can go ahead and say that the corresponding segments of the triangles are also going to be congruent. For this final step, we can conclude that segment DH is congruent to segment FK by CPCTC. Here are those final triangles again by themselves. And by rotating triangle FEK so it's facing the same way as triangle GDH, hopefully it makes sense here that segment DH is corresponding to segment FK and that they are congruent. And there you have it. Over the course of 10 different statements and 10 different reasons, we were able to prove that segment DH is indeed congruent to segment FK. If you found this video helpful, please consider giving it a thumbs up, and as always, keep up the great work.